Good afternoon, and thank you for attending today's third Smart Manufacturing Hub presentation featuring Infosys. My name is Nick Smith. I'm the Director of Corporate Partnerships at SME, and I have the pleasure of introducing our next speaker, Dr. Ravi. Dr. Ravi is the Associate VP and Head of Advanced Engineering Group at Infosys with 27 years of research and industrial experience. His areas of interest include aircraft structures, knowledge-based engineering, composites, artificial intelligence, robotics, and Industry 4.0. He is the author of 45 plus technical papers in various journals, conferences, and other external forums. And he has 2 patents to his credit. He makes me feel lazy, actually. Dr. Ravi's presentation today will be on Industry 4.0, applications and experiences in aerospace. But before I let Dr. Ravi take over, I want to encourage those in the audience to take one of these gift items that Infosys provided. It's a very cool Sprout pencil that I encourage you guys all to take home. But without further ado, Dr. Ravi.
Good afternoon. Am I audible? Yeah. First of all, let me thank you for this opportunity. It's an honor and pleasure to be here. Something close to my heart, talking about the Industry 4.0. Okay. So, if you look at the Industry 4.0 journey, and of course in the morning, there are many speakers who talk about the Industry 4.0 related aspects. And what I'll be focusing now is essentially the Industry 4.0, the applications and experiences in aerospace. Okay. So this particular slide, most of you are aware. This talks about the 4 stages of industrial revolution that has happened close to around 250 years back, when humans started using steam-powered machines to automate some of the manual processes that are there in the manufacturing shop floor. Then the next revolution happened when humans started using the electrical machines. We call it as electrification. The third one is essentially related to the industrial automation side of it, where we started using the robotics and the industrial automations and controls to automate a lot of these manufacturing processes. And now we are in the 4th stage of industrial revolution. That is basically the Industry 4.0. It is all about the cyber physical systems. The machines that are there on the manufacturing shop floor are intelligent enough to capture data about themselves, use that data effectively and efficiently to improve the manufacturing processes and operations. Okay? So that's all about the Industry 4.0. And if you look at very closely, what does it mean for the manufacturing shop floor? It's about the smart connected enterprise, and it's all about the IT OT integration. Okay? So IT means it's essentially the information technology that is getting connected or coming closer to the operational technology. The operational technology is essentially the machines that are there in the manufacturing shop floor. So here what is happening is, because of the convergence that is happening between the IT systems and the OT systems, there are a lot of things that are evident. One is the cyber systems are meeting the physical systems, and because of which you are able to capture the information much more faster than earlier, where the shop floor data is being captured at the top floor. And this is happening mainly because of various technologies that are coming together. One part, it is integrating the horizontal value chain. That is basically the horizontal integration that is happening. That is right from the supplier to the manufacturing shop floor to the end user or the end customer. That horizontal integration is happening at one sense. And in the other side, it is all about the vertical integration. It's basically connecting the shop floor with the top floor. Okay? And it's all because of various technology advances that are happening today. That is essentially the cyber physical systems, the smart machines that you are able to build, which can get connected to the next layers and things like that. Seamless interoperability standards that you are able to bring in. And the third one is advanced automations and control systems, which are essential for this technology transformation. And fourth one is essentially centers around the data, the big data, the large amount of data that you are able to aggregate and analyze that data to derive a lot of insights from the data. And the top, but not the least, one is essentially the smart services, the smart applications that you are able to build and utilize it for a particular purpose. Okay? So all these technology dimensions are coming together, enabling this fourth revolution for the industry. What does it mean to the end customer? So it essentially helping organizations in two ways. One is to improve the top line by creating new products and new services. At the same time, it is also helping organizations to improve their bottom line. So the bottom line improvement is essentially the efficiency drive. Okay? So because of this efficiency drive, you are able to pull out a lot of redundancy in the system through these advanced technologies, and also you are able to make decisions much better and much faster. Okay? So this is what the direct implication of the Industry 4.0. It's essentially giving competitive advantage to the organizations to improve their efficiencies and also improve their top line in terms of the business growth. So if you look at the efficiency dimension, which is more like a low-hanging fruit for a manufacturing organization, which is easier for them to implement or incorporate. And this particular slide, it gives a kind of perspective, what kind of efficiencies that can be realized across the manufacturing enterprise. So it starts from the engineering efficiency, then the supply chain efficiency, then the third one is all about the manufacturing shop floor. It's all about the manufacturing operations. So there are 4 dimensions of efficiency listed here. One is the maintenance efficiency of the machines that you are using. Then the second one is the improving the operational efficiency. The third one is information efficiency. Fourth one is all about the energy efficiency and also the sustainability aspects of it. Post the manufacturing shop floor, once the products are with the end customer, it is all about the service efficiency. Okay? So if you look at each of these efficiency dimensions, in fact, that will give you a kind of quick framework on the business value that you can realize from this particular journey. The bottom, you can see the numbers that are there. These are the numbers based on our study, based on our own experiences of implementing this, the kind of business value that you can get. Okay? So if you look at the energy efficiency, close to around 20 to 30% efficiency that you can improve, that has been mentioned here. But in Infosys itself, we are able to save close to around 50% of the energy by making all our infrastructure, that is basically the buildings that are there in our campuses, smarter, through which we were able to reduce the energy consumption. So it's around 50% savings we were able to achieve. The number that we have put here, 20 to 30%, is on the conservative side. Okay? So that's what I would like to stress upon. And although all those sub-dimensions that are mentioned in each of these major dimensions of the axes, if you look at closely, each one of them can give you a kind of use case that you can take it and implement in your manufacturing shop floor. So if you look at the maintenance efficiency, the first thing that one gets it is essentially the condition monitoring of the machines that you are operating. Okay? So these machines, how do you tap the information from these machines? These information is essentially the operations data, which you can utilize it to improve the performance of the machine, okay? Or to reduce the downtime of the particular machine, or to improve the safety aspect of that particular machine, or improve the reliability of the machine. So all those subdimensions come under that bucket. So that's a kind of key message that I would like to give as far as this particular slide is concerned. And in fact, this is a study that we are jointly working with leading German University of Aachen. And we started working with them for the past 4 years now. With them, we started defining this kind of framework, which you can take it and implement in your manufacturing shop floor. In fact, when you look at more closely the Industry 4.0 implementation, especially the manufacturing shop floor, you need to live with the legacy. Most of the manufacturing shop floors that you have today, some of them are as old as 100 years or 100 plus years. And there's a lot of legacy infrastructure that is around. You need to make sure that all this infrastructure is Industry 4.0 enabled without disrupting the operations. Okay? So that's where this particular slide gives how do you do that. You can create an alternate path through which you will be able to tap the information from the machines and use that effectively. In fact, that's what the alternate path that is being shown here, that is essentially use of some of the IoT gateway. So it's essentially a gateway which can get connected to various sensors that are there in the manufacturing shop floor, tap the information through this IoT gateway. It can get connected to the other layers. These are layers different from the conventional shop floor layers like the MES, the SCADA systems, and the enterprise asset management systems and things like that. So by doing this, what you will be able to do is essentially you are bypassing the path and making this legacy Industry 4.0 enabled. Okay? So that's what you are able to make, and the technology is available for that. So that's about the legacy industry. How do you make the Industry 4.0 enabled? And if you want to start an Industry 4.0 journey, essentially what you need is to have a kind of roadmap, where to start, how to start, where you should go, how you should go. That entire journey or the roadmap is being defined by the Industry 4.0 maturity index that we jointly worked with University of Aachen under the umbrella of Architect. So this is an Architect defined Industry 4.0 maturity index. This was released in 2017 Hannover Messe, April. And this particular maturity index will help you in defining the 4 stages of the Industry 4.0 maturity. Of course, the stages, 2 stages before is all about the computerization, connectivity. It talks about the Industry 3.0, but Industry 4.0 is essentially related to the visibility, transparency, predictability, and adaptability. These are the 4 stages that you can look at it. The first one is the visibility. So visibility is all about getting the data from the manufacturing shop floor as fast as possible, as better as possible, without having any issues and things like that. Okay? You should be able to get the data fast. That's what the visibility dimension is all about. Then the second one is the transparency part of it. Once the data is available, that data you can analyze, visualize, understand what is happening, getting a lot of insights from that particular data. That's what all about the transparency. Then the third one is about the predictability. Once you understand the nature of the data, how the machine is performing, and how well that can be improved, and things like that, then it's all about the prediction part of it. In the sense, you can predict the remaining life of a particular machine, how long that particular machine can live, and how fast you need to replace a particular subsystem in that particular machine, and things like that. So that's all about the predictability. Then once you have very good understanding about the predictability part of it, and you are able to make good prediction, it all about, next journey is all about the adaptability. So that means the machine's taking control of its own and then adapt it to the particular situation and things like that. So that's the highest level of maturity that is on the adaptability. So this entire framework that is available on Architect website, in fact, it is also available on our Infosys website. If anybody wants a detailed information about this maturity index, you can go and get that. And if any of you are interested, you can send me a mail. I'll pass on those details. We can send you that information. And this particular maturity index was developed under the umbrella of Architect with 5 leading universities of Germany, and those are the university partners that you can see with whom we have worked. These industry partners includes the Fraunhofer Institute, the University of Paderborn, and other universities. And also we have an industry partners who collaborated with us in defining this particular Industry 4.0 maturity index. Coming to the next slide, this is all about, okay, we talked about the Industry 4.0, what it is and where all it is impacting and how the journey should be. And in fact, there are multiple technologies that are coming together to define the roadmap of Industry 4.0. And these are some of the technologies. They can be a real-time visibility side of the technology, then the digital twins that you have, which will connect the entire enterprise, connecting the data from one end to the other end. It can be the manufacturing Internet of Things, the blockchain-related stuff, the cloud-related aspects, the robotics, and augmented reality, virtual reality kind of stuff, and the big data. So it's essentially a kind of convergence of multiple technologies coming together to realize a particular business value. So that's all about the Industry 4.0 technologies. So having looked at the Industry 4.0 perspective, we can look at more specifically in the aerospace segment, where and how Industry 4.0 can help. Aerospace industry, unlike other industries, is one of the most complex industry segments. It has multiple stakeholders. It's a huge life cycle. It's almost like 30 to 40 years that one need to plan for a typical aircraft from its inception to the retirement stage. And there are so many players or stakeholders that are involved: the OEMs, the Tier 1 suppliers, Tier 2 suppliers, the airliners, the operators, the MROs, and things like that. So it's a kind of complete, it's a very difficult industry segment, and that's where we believe Industry 4.0 concepts can help the aerospace industry in each and every stage of this particular manufacturing industrial aerospace life cycle. What we will do is we will focus more specifically on the manufacturing shop floor. And more specifically, the manufacturing shop floor, specifically on the composite manufacturing shop floor. Because most of the aircraft that we are building today, almost more than 50% of its composition is coming from the composites. So unlike the metals, composites has its own complexities, own challenges, and things like that. So essentially, if you look at a typical manufacturing shop floor, there's a set of raw materials or the subsystems that are coming into the manufacturing shop floor, and those raw materials are being processed to create an end component or end assembly. That's what a typical manufacturing shop floor does, and this gives a kind of typical information about a composite manufacturing shop floor. It has a lot of machines that you need to look at it holistically to improve the manufacturing shop floor efficiency. So this is a typical composite manufacturing shop floor layout in a layman's terms. So you have the clean room facility on one side, then you have the other machines like the autoclaves, the ovens, the non-destructive testing facilities, the routing and profiling machines, and the painting shops and things like that. And in the clean room, you have a lot of these cold storage, the testing labs, the automated tape laying machines, automated fiber placement machines, and things like that. So this particular facility, the composite manufacturing facility, if you look at holistically, if you want to implement any kind of Industry 4.0 technologies here, you need to concentrate on the facility where 80% of the issues can be looked at with the 20% of the assets. Okay? So here, the facilities that have been highlighted in the blue color are the most important facilities which you generally look at monitoring and doing some kind of predictive maintenance and measuring the parameters and things like that. These are the cold storage, which is essentially you need to monitor the temperatures and the pressures in the cold storage or the humidity so that you will not have any problem of damaging some of these raw materials, more specifically the prepacks and things like that. Then the automated tape laying machine, definitely this is a very important machine that you need to look at it. Any downtime of this particular machine will directly impact your throughput. Similarly, the automated fiber placement machine, of course, you will operate either the tape laying machines or the fiber placement machines, but both are equally important to create the initial component. Of course, once the particular component is created, that will get into the autoclave. Autoclave is one of the most critical assets for a composite manufacturing engineer, and which is more a kind of safety critical component which need to be monitored continuously. So autoclave is one of the important assets that you need to look at it holistically. Then the NDT, non-destructive testing facilities, that's also another important one where you will have a lot of this scanning equipment, and any downtime of that particular equipment you will not be able to afford. So in the previous slide, whatever we have seen, it contains all the layout of the machines. So if you want to improve the efficiency dimension that I mentioned about, how do you do that? So this gives a kind of next level of details about the efficiency dimensions, the operations efficiency, the maintenance efficiency, and energy efficiency, where and how you can do that. In the sense, you need to define the key performance indicators. These KPIs will give you a kind of dashboard, what is the kind of current performance of the composite manufacturing shop floor, where it should go, how that journey can be. Okay? So all that can be captured through these key KPIs. So For a maintenance engineer, it is all about the mean time to repair, mean time between failure, mean time to failure, and things like that. Similarly, for an operations guy, it's all about the OEE, operational equipment effectiveness, which you need to look at it very closely. For the energy efficiency guy, it's all about the energy savings, the sustainability aspects of it, how do you reduce the wastage and things like that. So all those things have been formulated and put it into a kind of matrix which you can use it. And I'm just going down one level down, that is basically the maintenance efficiency. If you look at any maintenance efficiency, how do you improve a maintenance efficiency of a particular machine? You need to look at the failure modes of the machine and track those failure modes through the sensors and the devices so that you will be able to understand the nature of the failure that is happening on the manufacturing shop floor, compare that with the design office or the engineering office, correlate between as designed versus as operated the performance and things like that. So for that, you need to have a very detailed information about the failure modes. In fact, these are the 4 facilities that I have just listed down, and each one of them has their own facilities. Like the autoclave is most critical equipment. You need to monitor each and every subsystem of autoclave, understand each of its failures, what are the typical parameters, thresholds that will get into this kind of trouble and things like that. So that gives you a kind of perspective where to focus and how to focus as far as the maintenance efficiency is concerned. And of course, this is one typical schematic diagram of an autoclave. Autoclave itself is not a single system, but it is a system of systems. There are a lot of pumps that are working together. There are a lot of valves that are working together. There's the pressure vessels that need to be monitored continuously. So what you need is not one component or one asset kind of perspective, but you need to have a systemic approach where you can monitor system of systems. Then only you will be able to get that kind of benefit and value out of the exercise, what you are building. Of course, so having said that, systemic performance, so when you deep dive further, how do you do that particular autoclave efficiency? It's all about improving the operations efficiency of the autoclave, reducing the energy consumption of the autoclave, and also at the same time, you should be able to identify the failures of a particular autoclave subsystem in advance, well in advance. So this entire thing can be done by collecting the data, analyzing the data, and of course the machine learning and AI can play a vital role here in improving this overall systemic efficiency. So in order to do this particular systemic way or systemic approach, what we have done is 2 of our partners came together. In fact, we are jointly working with Poiru, who is a leading EPC giant based out of Europe, who is helping us with this systemic modeling, that is more specifically the RAMS modeling. They call it as reliability, availability, maintainability, safety related aspect of a system. So they bring in those system models, and we have another partner, Nokia, who is helping us with their connectivity, the networking facilities and infrastructure. Through that, we are able to collect the data from this infrastructure, and we bring in our own platform, Infosys NIA, which is an AI platform to capture this large amount of data and analyze this particular data and use that data to improve the efficiency. So this is essentially a framework, a platform that we have built called Drishti 4.0. It is essentially all about getting deeper insights. Drushti in Sanskrit means it's a view, it's a getting insights, it's deeper understanding of a particular system. Okay? It's a fourth generation system, that's why we call it as Drushti 4.0. It has all these components. So if you look at the Nokia Impact platform, it collects all the data from various devices and sensors. Then you have the other information, that is basically the enterprise information, whether it is the PLM data or the P&ID information, that all comes from the enterprise systems that gets into the big data platform Infosys NIA. Then we will use these system models, that is the RAMS model coming from the Pyro, to give a kind of systemic, holistic perspective. Okay? So that's what we're doing here in the Drushti 4.0, and that gives a kind of real-time dashboards about the systemic performance of the system. That's about the availability, the mean time to accumulation, and the reliability. It's all about the RAMS models, the reliability, availability, maintainability, safety aspects, all that KPIs that you can monitor and then use to improve the efficiencies. So this particular platform will help in 4 ways. One is it will help in preserve and improving the know-how, that is basically the knowledge that you can capture from the manufacturing shop floor. It will help in reducing the risks that are involved in the manufacturing operations. It will give the enterprise oversight. It will help in reducing the costs and increasing the benefits. Okay? So that's about this particular platform. In fact, I have a small demo video which I would like to show now, and that gives a kind of perspective about Drushti 4.0 platform, how it is being used in the power plants today. A power plant, you can imagine, you can replace that with a composite manufacturing shop floor or any other metallic manufacturing shop floor. That's it. Any questions from anywhere?
Thank you, Dr. Ravi. If anybody has a question, please raise your hand. I can run the mic over to you.
Oh, okay. That one? Oh, okay.
Any questions? I guess we don't have any questions, Dr. Ravi. All right.
Thank you.
Oh, hold on. Oh, we do.
Oh, okay.
Hello. I just need to know a little bit about the cost. Like, how much cost would it be applicable for a small and medium enterprise to upscale to a standard level of an IoT applied technology?
So if you look at the cost-wise, probably the way you need to see is what is the kind of asset that you are trying to make it IoT enabled. Okay? So the criticality of the asset is very, very important. So in the composite manufacturing shop floor, the example that I have given you, the autoclave is one of the most critical asset there. Enabling autoclave IoT or IoT enabled autoclave is very, very critical. The reason is you can capture the data real time and you can do the condition monitoring of that particular asset. Any downtime of that can lead you to a reduced productivity and things like that. So you will have very good business value associated with it if you want to implement an IoT. Okay. Whereas the other side of it, if any non-critical asset is there, if you make it IoT enabled, it really doesn't give you that kind of benefit. So you need to look at it holistically, looking at the criticality of the system, the complexity of the system, then you need to assess. On an average, the value that you can generate is close to around 30% minimum you will be able to get in terms of the cost or the investment that you are putting it and also the return that you are getting. Okay. Does that answer your question?
Do we have any other questions for Dr. Ravi? Got another question for you, Dr. Ravi.
Oh, thank you.
Well, it bounces off of the previous question. Maybe you can give us an example of a cost for an upgrade that you have performed so far for a maker?
Okay, so let me give you one example. This is on a shop floor, which is more like a metallic shop floor, which has a typical machine, which is like a spindle machine that was there, which is a kind of a legacy machine that is there for quite some time. We have made that legacy machine the IoT enabled, putting that IoT gateway and tapped the data coming from that particular spindle machine and use that data to predict the next failures and things like that. More so for that particular spindle machine, one of the critical thing that we looked at is the consumables. There are certain parts or consumables that need to be replaced continuously. The way that is happening now, the the replacement of those the components is done through a time-based schedule. So every 2 months you replace this, every 3 months you replace this kind of scenario. Now that we have moved away, rather we are doing that kind of maintenance activity based on the condition of that particular machine now. Okay? So whenever the performance of that particular spindle machine coming down and we are assessing why that particular performance degradation, what is the kind of component that is related to it, looking at only that particular component and replacing it. So in a way, what you are able to do now, earlier you are doing that maintenance once in 2 months, now you are extending it to once in 3 months or once in 4 months, depending on how that particular machine is used. Okay? So that's where the benefit that comes in. And also, because you are monitoring the condition of that particular machine continuously, you are able to improve the safety, the reliability, and also the availability of that machine. So there are many indirect things that you are able to capture, which you can put it into the business value matrix, and that's where I'm coming to the 30% minimum that you will be able to achieve. Okay.
Do we have any other questions for Dr. Ravi? All right. Dr. Ravi, I don't think we have any more questions for you. Thank you very much. How about a round of applause for Dr. Ravi?
Thank you. Thanks a lot once again.